Okay, question 12. So, a new air conditioning unit was purchased for $5,000 on the 1st of January 2019. On the 1st of January of each year after 2019, its value is depreciated by 20%. Okay, depreciation. So let's take our minds back to our depreciation chapter. Using the declining balance method. All right, declining balance method, depreciation. We know what formula we're using. We've got a formula for that. S equals V0, 1 minus R to the power of n. That's the declining balance formula. So we know we're going to have to use this. We know that S is the salvage value or the current value. So it's kind of like the future value of the air conditioning unit, okay? This is the initial value here, V0. So that's going to be our $5,000. That's how much it was when it was brand new, when we bought it. And this value here is the new value after it's depreciated. It's gone down in value because it's no longer new. There's newer and better air conditioning units on the market now. All right. R is the value that's the rate at which it depreciates, sorry. So in this case, it's 20% each year. So the rate will be 20%. And N is the number of time periods. So that's going to be the number of years. And that will tell us what the salvage value is. Okay, the value of the air conditioner will be below 1,500 for the first time on the 1st of January. Oh, okay. So they're actually asking us what year. So they're asking us for N. They're not asking us for the salvage value. They actually gave us the salvage value. They said, when's it going to be below 1,500? So we want to know when this becomes 1,500. And then after that point, we know that it's going to be below 1,500 because it's only going down in value. It's not going up. So if we put 1,500 in there, that's our value for S. What's our value for V0? It's just that 5,000, the initial value. Our value for R, we said was 20%, but if we want to write that as a decimal, how do we write 20% as a decimal? 0.2. And then N, this is what we're trying to find. This is our question mark. This is our unknown, all right? So let's plug all our values into the equation, see what we get. So we've got 1,500 over here, 5,000, 1 minus 0.2 to the power of n. We still don't know what n is. So we're trying to find n. So we need to solve this equation. Let's try and get rid of everything that's around n. So over here, we can get rid of this 5,000. We just need to divide both sides by 5,000. They're going to cancel out. We got rid of it. And over here, 1,500 divided by 5,000, you can do it on your calculator. It's 0.3. Okay, so now we're left with 1 minus 0.2 to the power of n. We can do this because this is just two constants in here. We can do 1 minus 0.2. So let's do that. 1 minus 0.2 gives us 0.8. I don't know why I just did that on the calculator, but it's never a problem to do it on the calculator because, you never know, you might make a silly mistake. All right, so now we've got this equation here, and we don't really know how to undo this part. So what the solutions actually tell you to do is they just want you to trial and error again. So this quiz loves its trial and error questions. So we're just going to substitute in values of n. So we can substitute in n is 1 year, n is 2 years, n is 3 years, and we're going to see if we get close to 0.3. So after 1 year, let's see what happens. Is it 0.3? After 1 year, it's 0.8 to the power of 1. So it's just 0.8. Is 0.8 anywhere near 0.3? No. So it's definitely not to the power of 1. It's not 1 year. Let's try 2. 0.8 to the power of 2, or 0.8 squared. Is that going to be close to 0.3? 0.64. So we're not at 0.3 yet. We've got long ways to go. Let's try 0.8. Let's skip ahead a bit because we're not really anywhere near 0.3 yet. So let's say 0.8 to the power of 4. Okay, so 0.8 to the power of 4 gives us, first of all, let's write this in. It gives us 0.41, so that's pretty close. We're getting closer to 3 now, so we need to keep going. What about 0.8 to the power of 5? Is it 0.3? 0.8 to the power of 5. Ooh, we're very close now, 0.33. So I'm guessing it's going to be after this year. I think it's going to go below 0.3. It's not below yet, so it hasn't reached $1,500 yet. But once it goes below 0.3, then we know that it's going to be that amount of years at least. So let's try it. 0.8 to the power of 6. 0.8 to the power of 6 is, we got it, 0.26, which is now below 0.3. So after 5 years passed, it wasn't quite at $1,500 yet. But after 6 years passed, it went below. So it reached 0.3 and then it went under. So it reached $1,500 and then it went lower than $1,500. So we have 6 as our answer, 6 years, but we're not finished yet. Remember, we purchased the air conditioning unit on the 1st of January 2019. And then 6 years later, so we need to add 6 to 2019. 6 years later, the value went below $1,500. So 2019 plus 6 gives us 2025. So it will be the 1st of January 2025. So our answer is D. Oh, they made that really complicated, didn't they? Okay, so question 15. First of all, we need to fill out all of our earliest starting times, and then we need to work backwards and fill out all of our latest starting times. And you can see straight away from the question that they've given you space to do that. So that's a pretty good place to start. Okay, so we're starting with 0. We always start with 0, and we fill out the left-hand side first, which is the earliest starting time. Okay, now we go on. If we want to go up here to this next one, there's only one pathway that leads there. So it's just going to be 0 plus 2. It has to be. There's no other pathways. This one here, again, there's only one pathway leading here. So it's 0 plus 1. And again, only one pathway that leads here. So 0 plus 5. All right. Next one here, there's only one pathway again. So it has to be 5 plus 2. So that's nice and easy. This one up here, there's 3 different edges leading to it. So there's 3 different pathways. So we'll leave that for now until we know all 3, because at the moment we only know these 2. We need this one first. So up here, how many pathways lead to this one? Only this one here. So that's nice and easy. 2 plus 3, 5. All right, now we've got all 3 pathways that lead to this one. So we can choose which pathway we're going to choose. Well, when we're doing the earliest starting time and we're moving from the start to the finish, we always select the pathway that takes the longest amount of time, okay? So we have to factor that pathway in. So in this case, we've got 5 plus 2, which will give us 7. Here we've got 1 plus 4, which gives us 5. So far 7 is the longest pathway. And down here we've got 7 plus 1, which is 8. So this is actually the greatest value. So this is the one that we're going to put in, 8. Now we're moving on to our next one. Okay, so how many pathways lead here? We've got this one and this one. So we've got 2 possible edges leading towards this vertice. So this option up here is 5 plus 6, which gives us 11. And this option here is 8 plus 7. Which gives us 15. So 15 is the greater value. So 15 is the one that we'll use. And then there's only one edge here that leads to the last point. So it's 15 plus 2, it has to be. Okay, so now we've got our earliest starting time. And our latest starting time is also going to be 17 now. And we're going to work backwards to fill in the right-hand side of the boxes. Okay, so there's only one arrow that leads back here, so it has to be 17 minus 2, so it's 15. Now, if we were to do this one, Well, there's actually 2 arrows that lead back here. If we follow these backwards arrows, we follow these arrows backwards, there's 2 that leads here. So we need to know this one first before we can choose which edge we're going to follow the pathway along. So we will leave that one for now because we don't have this. Can we fill in this one? How many edges lead back here? Only 1, okay? Because these edges are going forward. We need the one that goes back along the arrow backwards. So this one is 15 minus 7. So that leaves us with 8. So you can see that this is the critical path so far because these are the same, these are the same, these are the same. So critical path is going to come along here. Okay, now we can do this one because we've got 2 options. We can do 15 minus 6, which gives us 9, or we can do 8 minus 2, which gives us 6. And now when we're working backwards, we don't take the largest value anymore. We have to take the smallest value, okay? The shortest time. So 8 minus 2 is the shortest, so it has to be 6 up here. We can go here and do this one because there's only one path leading back, so it's just 6 minus 3. What else can we do? We can't do this one yet because there's all these different pathways leading back, so we need to know these. We can do this one because there's only one path that leads backwards here. So it's 8 minus 4 is 4. We can do this one because there's only one path that leads back here. So it's 8 minus 1 is 7. So you can see this is the critical path because the earliest starting time and the latest starting time are the same. So that leaves it with no time to spare. And then this one again, there's only one path leading back here. So it's 7 minus 2. So we're still on the critical path, but we have to be. We've got no choice. There's nowhere else to go. And then we can decide this one. We've got 3 different options and we have to choose the smallest value. So 3 minus 2 is 1. 4 minus 1 is 3, so it's not that. 5 minus 5 is 0, so that's the smallest value clearly. So the critical pathway is from here to here, up here, and then out like that. So that's the critical pathway. Now, what's the question actually asking us? So it says if activity G is delayed by 5 hours. So where's activity G? So activity G is up here. It's got an earliest starting time of 5 hours and it's got a latest starting time of 6 hours. So that means that this activity can start at 5 hours, but it can also be delayed by 1 hour and start at 6 hours. So that means it's got a float time of 6 minus 5, or 1 hour. It's got a float time of 1 hour. So that means that we can actually delay this activity by 1 hour and it's not going to affect the total time for this process to be completed. So the question asks us to delay it by 5 hours. So for the first hour, it's not going to affect it. But for the remaining 4 hours, that's going to delay the whole thing by 4 hours, okay? So the question says we're going to delay it by 5. How much is that going to delay the whole thing by? How much is that going to delay K by over here? Sorry, it says how much will K be delayed by, and K is right at the end over here. How much will it delay the critical path by? Well, it doesn't matter about that first hour because we've got a float time of 1 hour. But the remaining 4 hours, it will delay this critical path by 4 hours. So your answer is basically going to be the amount they asked you to delay it by minus the float time, which is 1, okay? So it delays the process by 4 hours. So it delays K by 4 hours.